I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. In this video, we are going to discuss how do we calculate gradients. Most of the applications will use the term rate of change, and in North America, we use slope as the term for gradients. So they are all kind of same things. The objective is how do we read the coordinates of points on a coordinate plane. So you can see a coordinate plane here which has the horizontal x-axis and the vertical y-axis. Coordinate points will be x1, y1, which we'll see how do we read them. And then after doing that, we'll see how do we find gradient of line joining the points. We have to start with basics because at times I've seen students mixing up x and y coordinates themselves and therefore getting wrong solution for the gradient. Well, let's also get to the definition of what a gradient is and how can it be calculated. So normally we represent gradient or slope by the letter m. It is called rise over run. So for any particular line, it could be rising or falling. Change in y coordinates gives you the rise and change in x coordinates give you the run, which at later stage we do write as delta y over delta x. It really means change in y coordinates. It's a short form which even middle school students can use. And then, what is the change from one point to the other? Is basically difference in their y values, which is y2 minus y1 divided by the difference in x values, x2 minus x1, right? So it's kind of important to understand that when we're talking about 2 points, right, let's say these 2 points, right? So let's call them these points as m and n, for example. And the coordinates we assign as x1, y1, then the other coordinate will be different. So we'll say x2, y2, right? So y2 minus y1 means first we do the difference of the y values. You get the idea. Maintain the order. Maintain the order means if you are doing from y2 take away y1, then you have to do also from x2 take away x1. Do you understand? So the order should be maintained. So x2 minus x1 is in the denominator. y2 minus y1 is in the numerator. So that will give you the correct value of gradient or slope, right? So that is how you find the slope. And then we will relate the values which we have found for gradient with the graph actually. So let's begin with the questions at hand.
After attending university, the winner of this year's Certificate of Achievement Schulich Leader Award is Akshi Kandivani.
Great. Our student Akshat gets highest marks and the most prestigious Schulich Leader Award. You can be there. Join our classes and excel. So I've kept it very simple. You can see this small diagram where we have only 4 lines, correct? So we have a line which is rising, we have a line which is falling, we have a line which is horizontal, and we have a line which is vertical. So that gives you the variety which we really need, right? So once you understand the gradient of these lines, you are in a position to find gradient of any line, right? Gradient of any line. So that is the idea. So the questions before you are very simple. Find gradient of the line segment shown in the figure. Well, many times we are actually finding gradient of a line, not just a line segment. Now, let's understand the difference. When I have a segment, then I'm only saying, let's say from here to here, right? That is a segment. It has boundaries. However, even if I extend this particular segment, right, it becomes a line, right? You see that the gradient of this segment, which is contained in a line, is same as the gradient of the line also. But if you are given a line, you need to identify at least 2 points to find the gradient. So either way it works. So basically, on a line also, you are identifying 2 points. We call them point 1 and point 2 with coordinates x1, y1 and x2, y2. So their quotient of their difference, you see quotient means divide one by the other. So rise over run, basically, let me repeat, change in y over change in x. Quotient means we are dividing change in y by change in x to get the gradient. Get the idea? So the question is straightforward. You need to find the gradient of these 4 segments. Perfect. So I've labeled them as AB, OP, HR and VT. Okay. So before we get into calculations, let's first understand what do we expect and how can we relate this gradient with the segments or lines themselves. Remember one thing, that when you look at a graph, we should always see it from left to right. You understand? You see it from left to right. So that means if my graph is like this, it means it is rising. You understand? This line is rising. Gradient gives you the steepness and how steep it is. This is also rising. It is much steeper than the other one, right? On the other hand, if I have a line like this, it is falling, right? So which is negative gradient. In the first case, it was a positive gradient because it was rising. Now it is a negative gradient. So we expect a negative value if the line is falling, going down the hill, right? So that is how we should do it. And of course, if the horizontal line is being considered, in that case, it is clear that it is neither rising nor falling. You get the idea. So what should be the value of the gradient? Think about it. It is not positive nor it is negative. Makes sense, right? Okay. So let's review this concept. So gradient, rate of change and slope of a line are same things. Let's understand that first, right? Because if you are using international books, you might come across different terms which really mean the same thing. Gradient is a measure of how steep it is. Gradient is positive if the line is rising. Gradient is negative for a line going downwards. Horizontal line has zero gradient. Vertical line has undefined gradient. Undefined means like steep. Steep like climbing a wall. It is such a difficult job, right? So kind of impossible. So you cannot find that gradient. We say it is undefined. Horizontal means walking on in your house on the floor, right? It's so easy, right? There is no gradient in it. There is no slope there, correct? It is zero slope, you can say. It's just horizontal, leveled ground. Is that clear to you? Now, these are common terms which you can relate with the mathematical terms, and that is where it becomes interesting, correct? So once again, the formula to calculate the gradient, which normally is given by the letter m, is change in y over change in x. Remember, change in y comes on the numerator side and change in x is on the denominator side. Is that clear to you? Perfect. Now I think you're ready to answer these questions. So let's start with the very first one. It says, find the gradient of the line segment AB. So the line segment AB, I'm going to highlight here, is this one. You need to find the gradient of this line. Now, very first step here is to identify what are the coordinates of A and B. Some students struggle in finding the coordinates. So let's read the coordinates, right? So let us assume this is 1 unit on this side and this is also 1 unit. So we'll count. A is 1 unit to the right. So for the coordinates A, we can write x value as 1, right? So when I say coordinate values, we are taking this as the x-axis and the other one as the y-axis. And therefore, any point here, for example, will be, first we'll write the x value and then we'll write the y value. Okay? X means the horizontal distance from the origin, okay? And y means the vertical distance. You get the idea. So from here, we have to move 1 unit to the right, as you can see. So x is 1. And then we are going 2 units up, right? 1 and 1, correct? So y value is 2. Is that clear to you? So that is how we get the coordinate points of point A on this particular system. Okay. Point B. Point B, let us see how do we reach point B. Now point B, we have to go along this path 1, 2, 3, 4, 5 and one more 6, right? So this is 6. So that gives you 6 and then up we go 1, 2, 3, 4, 5 and that is how we find the coordinates of point B, correct? Sometimes it is a good practice to write them right there. So we can write 6, 5 here. Make sense? And let me write A as 1, 2, right? So let me write 1, 2 here for coordinate point A. So we got these coordinate points and now we want to find the gradient or the slope of the line AB. So I prefer to write with the letter M, which gives you slope, and AB as subscript. So that means I am finding the gradient of the line segment AB. You see the nomenclature, the way we have written, it helps to read and explain, right? And as we can see from the formula, it should be y2 minus y1 over x2 minus x1. Now you have to identify from A and B, which is point number 1 and which is point number 2. Normally, you should take left point as 1 and right as point 2. So this we'll consider as the second point. You get the idea. And that we'll consider as a first point. Perfect. So now clearly, we could write down these values. 5 minus 2 comes in the numerator, right? So 5 minus 2, which is to say, we have to take away 2 from 5. And that comes in the numerator, not in the denominator. And what comes in the denominator is x2 minus x1. x2 is 6. So it is 6 minus 1. Perfect. So the values which we have taken in the denominator are now these values I am highlighting, which are 6 and 1. You get some idea now, right? So this is what comes in the denominator. Now it is a simple math, right? Dividing means quotient. Sometimes we use the term quotient, right? So the slope from A to B is 5 minus 2, which results into 3, and 6 minus 1, which is 5. So 3 over 5. Now we prefer to write as a fraction or a rational number. So I'd like you to leave the answer. So this is our answer. Is it okay? So leave answers as fractions. Or we prefer the term rational number. What I'm saying here, do not convert to decimals, right? Avoid decimals. Until and unless it is specified in the question itself. So here the question is not telling you in which way you have to write. So that is the exact value. You get the idea. Sometimes when you convert fractions or rational numbers to decimal numbers, you do not get exact values. You get repeating decimals, right? So I hope this is absolutely clear. Now let's review this. When I say 5 minus 2, I am saying rise, correct? So this is what rise is. So rise over here is from A to B. This is the rise. Do you see that rise? And how much is this? This point y value is 5 and this is 2, right? Let's make a triangle. So this rise here is 5 minus 2, which is 3, correct? So that is the rise. And the run here is, when you go from A to B, run this much, right? And then rise that much. You get an idea? So this is the run, right? This is the run. From 6 to 1, do you see that? From 1 to 6 you can say, which gives you the value 5. You get the idea. So that is how we find rise over run. And since we are going up, means positive. Is that clear to you? And therefore, this answer is positive. So you can correlate your answer with what we just calculated. Is it all clear to you? Perfect, right? Now, if you really need professional guidance and excel, in that case, you can always contact me on the email address given or at our website. Perfect. Let's move on and take the next question now, which is, we again want to find the gradient, and this time let me highlight the gradient of the segment OP. So segment OP is right there. So OP can be read as PO also. The gradient remains the same, right? So it is one and the same thing whether we read it as OP or PO, right? I write OP in this particular case like opposite. You understand? We'll just see that. So first point, can you please read the coordinate points of O and P? Right. So O is the center value. Do you see that? O is the center value and origin points are 0, 0. As far as P is concerned, you have to see how do we reach P. Now to go to P, I have to go left 1, 2. So this is minus 2. Do you see that? So we have minus 2 and then we go up 1, 2. So up means positive. So we get the coordinate point. So P as minus 2, 2. Make sense? Perfect. Now you'll apply the formula and M is the gradient or the slope from O to P. From O to P. So the formula is y2 minus y1 over x2 minus x1. Correct? Now O to P, that means P is your endpoint. So first we'll write P values. Is that correct? And first we will write what? Y values on the top. Y values means difference of these two, correct? So we'll write here 2 minus 0. And then we are going to write in the denominator difference of these two. Which means what? Which means minus 2 minus 0. And therefore, we get the slope OP as equals to 2 minus 0 is 2. And then we have minus 2. And when you divide, you get a negative number. Negative 1. Do you see that? Now, clearly, the line here is falling, correct? The line here is falling. So, falling line, correct? So, that means negative slope. I am writing gradient for slope. Both are same things. Do you see that? Going down the hill. So, whenever you're going down the hill, the slope will be negative. And therefore, check your answer. If it is negative, it looks okay. So, that means rise over run. Rise is actually going down, which is negative in this case, right? So you can also go like this. Rise is 1, 2. So negative 2, right? And run is 1, 2, positive 2. And you can calculate this as negative 1. You get it? So you could also straight away read rise over run from the graph as I just showed you. Does it make sense to you? Perfect. Okay. So you can see for yourself how easy, simple it is. Perfect. Now let's go on to solve the next problem, which is find the gradient of the segment HR. Identify the segment HR on the coordinate plane. Can you see it? Yes. So first step, can you tell me what are the coordinate points for H and R? So coordinate points for H. If I have to reach H, how will I reach? Okay. I have to go left and then 1 unit, right? So that means I'll write 1 here and then up 1, 2, 3. So positive 3. Okay, so that makes sense. So I got HR as 1, 3. Now let's go to R. To reach R, I have to go 1 unit to the right. So I can write R as 1 to the right and then up 1, 2, 3 again. So 3 up. So we reach R. So the coordinates of H and R are 1, 3. Well, H was minus 1. Sorry, we went left, right? So it is minus 1. My mistake. So H coordinates is minus 1, 3 and R are 1 and 3. You see, it is a horizontal line. You can see that this is a horizontal line. What do you expect from a horizontal line? What should be the gradient? What should be the slope? Well, it is neither rising nor falling. Then what should be the value be? It is neither positive nor negative. It is what? It is 0. Perfect. Let's calculate. So let's calculate slope HR. Formula y2 minus y1 over x2 minus x1. Difference of y values 3 minus 3. Do you see? 3 minus 3 in the numerator. 1 minus minus 1. Put it in brackets, right? Now when you open this bracket, then you can now calculate the slope 3 minus 3 is 0, and 1 minus minus 1 should be written as 1 plus 1 or 0 over 2. 0 divided by any number is 0, and therefore the slope for this is 0. Clear? So quickly we came to our answer, which is exactly what we thought about. Perfect. So HR, the horizontal line, has 0 slope. Makes sense? Good. Any doubts? So any horizontal line for that matter, if I draw, will have 0 slope. For example, if I draw this line horizontal, correct? Can you find the slope for this? Let me call this as ST. Now, since it is not rising, not falling, right? So we know M is 0. You get the idea. Very important. And what is the equation? Do you see the y value in this case is constant? In this case, I wrote as minus 2. So y value is minus 2. We'll get to the equation of lines later, but that gives an idea. Every point here has the same y value. Do you see the y value for HR? It is 3. So if the y values are same, then the line is horizontal. Correct? So line is horizontal if y2 equals to y1. You get the idea. Okay, let's move on and take up the last example. Now this time we are going to find the gradient of the segment VT. So let us identify where the segment VT is. Right there, right? At x value of 5. Okay, so at x value of 5, we notice that y values are different. For same x value, we have different y values, right? Let's find out the points. For VT, V is what? So x value is x is equals to 5, right? Let me write down 5 here for x. And the y value is, we just go 1 unit up. So 1. As far as t is concerned, the x value is 5. And how much do we go up? We go up by 1, 2, 3, 4, right? So 4. So that is how we get to these points. X values are same. That means you are rising. Like it's a high building, steep building, right? It's like a wall. So now, what is the slope from V to T? So the slope will be, as we said, y2 minus y1 over x2 minus x1. The y values are different, as you can see, 4 and 1. So let's write down these values. 4 minus 1, and now the x values, which are same, 5 and 5. So let's write down these values. 5 minus 5. So this time, it is 3 over 0. 0 is in the denominator, not in the numerator. When you have to divide by 0, can you divide anything by 0? You cannot. It is not possible, right? So we say not possible or not defined. So this is a very important term. It is not defined. So a vertical line slope is not defined. So let's note here. Vertical line slope is undefined. Is that clear to you? And vertical line really means that the x value is constant, right? So x value I may write as k is same. So in this case the x value is 5 and therefore the line could be written as x equals to 5. You get the idea. So for horizontal, y value is constant, and for vertical, x value is constant. So with that, we come to an end of understanding how do we find the gradient of a line segment. Same is the procedure for line also. You have to identify 2 points on the line to find the gradient. So now, can you please summarize your learnings? So in this particular video, we learned 2 things. First, we learn how to read the coordinates of the points. So whenever you read the coordinates, you write the x value first and then the y value. Perfect. Then we find the gradient of the line joining 2 points. And the formula used was change in y coordinates over change in x coordinates, right? So that is kind of important to understand. But main thing is maintain the order, right? So maintain order. What I'm trying to say here is that if I take one value as x1, the other value is y1, and the second time I check x2 and y2, in that case, the order should be maintained. So I have to write this difference on the top. Do you understand? And then we have to divide by the other difference. You understand? So this quotient is what we have to calculate, which we write y2 minus y1 over x2 minus x1, and we call this as gradient m. Make sense? So maintain the order. And in the learnings about the gradients, what did you learn? What could be the gradient of a horizontal line? What could be the gradient of vertical line, right? So if I give you a line like this, right? So what is the gradient? And if I give you a line like this, what could be the gradient? And if I give you a line like this, what could be the gradient? And also, I could give you a line which is vertical. So in each case, we can say very clearly that in the first case, gradient m is positive. In the second case, the gradient m is negative. In the third case, gradient m is 0. And in this case, gradient m is undefined. So you'll get something over 0 divided by 0 is not defined. Perfect. So that is how we understand this particular topic on gradients, rate of change or slope, one and the same thing. In case you want to learn from me, you can always send an email on this, or I also have a business account. We can work together so that you understand the concepts and do much, much better. I hope that makes sense. Feel free to write comments and your suggestions. If you like and subscribe to my videos, that'd be great. Thanks for your time and all the best.